Hello, everyone. Welcome to the third session of our Mnova training series for those stuck at home. Obviously, not only for those, but probably the majority of you are at the moment. I am Santi Dominguez, one of the co-founders and CEO of Mestre Lab. And today, we wanted to take the opportunity to show you one of our specialist, what we call specialist tools. I've just been told off because I put Binding on my presentation, and apparently the product is called Mnova Binding, not Binding, but anyway, you will have to, the guys in the office will have to accept my shorthand today. Okay, so without further ado, first of all, wanted to remind you once again that we are running a series of this. We already had several in the last few days, so this will really be the fourth session. And we have a few others coming up, plus a number of others that will be scheduled after that. So keep an eye on that first link that you see there, online training, the free practical training series. You can also get to this through the Mestre Lab homepage. It should appear in the slide scroller at the top of the homepage. And also there are some webinars that you can view if you go to the events page. I will remind you about these at the end again. But let's move and talk about what we are aiming to do. So our objective today is to introduce you to Binding, which we see as a first-in-class tool for mechanistic studies in structural biology applications by using NMR data. This is what we have targeted with this specific plugin, but a lot of the functionality that you will see today may also be used in other contexts where, for example, you need to handle a significant number of 2D data, and you have an interest in following the evolution of peak positions, etc. So, you know, you can look at it a little bit as the objective that we developed it for, but also you may be able to find application in other in other fields. Okay, we want to give you understanding of the advantages and the unique features of the plugin and how it may help your workflow, particularly if you work in this kind of application, and to give you the tools today to start using the software by following the basic demo that Pablo will do after this initial presentation. Okay, so the format is the same as for a couple of the last sessions that we did. I'll do an introduction for about 15 minutes, and then Pablo will give us a demo that you guys can follow with the software licenses and sample data that you should have been sent prior to this webinar. We talked to Pablo after the session yesterday and asked him to go a little more slowly, so hopefully everybody can follow. Of course, if you still find it quick or for whatever reason you get lost along the way, we will share the recording of this webinar in the next 24 hours or so you will be able to practice at home. Just first of all, Binding is a plugin to Mnova. You can see it here, circled in what is the list of our specialist plugins. And as you know, Mnova has tools for processing NMR, mass spec, and optical spectroscopy data. And then we have built a series of different plugins which are targeting advanced applications, in some cases which are of general use, and in other cases what we call specialist applications, which means that normally there will be a subset of the user community that will be interested in this. In the case of Mnova Binding, probably mainly people working in structural biology and related applications. Like I just explained, it's an Mnova plugin. Now, what this means is that it's fully integrated within the standard Mnova architecture. The good news is that if you are used to using Mnova, for example, for processing NMR data, you are able to benefit from all the capability that is in Mnova NMR, but to drive a workflow which, if you like, is a little bit more specialized or more advanced. It's being developed as a workflow tool. And what we are targeting is structural biology researchers. We want to simplify, or the objective of the tool is to simplify complex NMR analysis, which is typically used to derive mechanistic activity information. So basically to get information on the activity of compounds in biological systems by using 2D NMR. this can be quite a complex workflow, and what we have tried to do is to implement it in a software tool that basically automates most of it and makes it as simple to use as possible. Experts in this field typically will use several tools to do the same job, and we've basically tried to bring it all into one environment. Simplify it. What does the software allow you to do, or what can you achieve with it? So it's designed to analyze protein titration data. So we assume that you are acquiring, you're titrating a protein with a ligand, and you're acquiring to the NMR data at the different concentrations, and that experiment can be used to extract binding affinities. And I guess probably a lot of the audience knows this already, but just in case we have some people from outside the structural biology field attending as well, to get more familiar with our tools, the binding affinity, it's basically telling you the strength of the binding interaction between a single biomolecule, the receptor, so something like a protein or DNA, and a ligand or binding partner, which will typically be a drug or some kind of inhibitor, activity inhibitor. Typically, we measure it in what we call equilibrium dissociation constant, or KD, and that allows you to evaluate and rank the strengths of the interaction between the ligand and the receptor. And this is basically what M-binding aims to, or the workflow that M-binding aims to simplify, so that you can get at this information much quicker. The workflow looks a little bit like this. So what you will have to do is, first of all, you acquire the data. I haven't included that in this slide because here I'm talking about the workflow of our software tool now of Mnova Binding. So assuming that you have several 2D spectra acquired at different concentrations, you will then want to import those into a processing analysis software and to superimpose them so that you can look at variations in the chemical shift and process them so that you can get good peak picking information. The objective is to track how the peak moves as concentrations change. And this is something that you could do in any NMR processing software in principle, but we have tried to make this process very easy by implementing some tools that Pablo will show us for importing multiple spectra, processing them all together, etc. Once you have processed the data, you would then want to relate the chemical shift variations to the concentrations of, in this case, the ligand, and to take the chemical shift values and put them in some kind of table where you can then analyze them. So this is something that typically people working with this kind of data will probably do in Excel, and it requires quite a lot of manual data entry. So we have tried to integrate all that in the workflow so that now it happens automatically within Mnova. No need to use Excel and no need to type any data, which not only does it take time, but it can also generate transcription errors. You would then want to probably generate a plot of the evolution of your chemical shift, the chemical shift perturbation, which you could do in Excel and in other plotting tools, and then to fit the chemical shifts to a model that will give you a KD. And this, again, people will probably do on Excel, the first part, and then maybe use a fitting or modeling software. For the second, in some cases, you may have complex models which are not a one-to-one relation, but you have higher parameter sets. And in this case, there isn't a lot of functionality out there. We have also, through collaboration with another Galician company called Affinimeter, implemented this within the software. And finally, you will want to report the results. Some people may go to Word or to PowerPoint or tools of this kind. Other word processors and presentation tools are also available. But again, we've tried to include all this within the Mnova Binding workflow. Features, I will say, are the ability to process many 2D spectra to extract useful information in a very automatic fashion, the ability to follow the chemical shift perturbation, so track peaks and how they move automatically. The software will compute the KD for you, so you don't need to implement any models in Excel or in any other tool. And as I was saying earlier, by using affinimeter or by integrating with affinimeters, you can also analyze more complex binding models. Idea, and you will see the software in a moment, you know, the workflow will be a little bit like this. Here we've brought in a whole bunch of 2Ds. We have followed the movement of certain peaks that we are interested in. We will see how we define that in the demo. So that now all the information is, after a couple of clicks, is all available for all the chemical shift positions for the different spectra in a simple to look something like this. And fully automate the analysis so that in the end, we end up with the KD information. But of course, we don't want to see this in PowerPoint. I think it's a lot more fun and interesting to see it in the software itself. So I'm going to give the stage to Pablo now, and he can show us how this works in the software. Now, the objective is that you guys can, by using the materials that you were sent with your registration email for the webinar, you can follow this and try to do the same that Pablo does, and hopefully by doing so, you can achieve similar results with the sample data that we sent you. Pablo, all yours.
Okay, thanks, Santi. Okay, first of all, as we were doing during the last workshops, I wanted to make sure that you are using the modern interface. So for those users who are still in the classic mode, please go to the Edit menu and select Preferences. Edit Preferences. If you are running in Mac, you will need to go to Mnova Preferences, and in the interface, make sure that you select the modern interface instead of the classic, so you could follow the workshop easy. So to change again the interface, go to Edit, Preferences, or Mnova Preferences, and change it from there. Change the theme from there. First of all, I'm going to load the datasets. I'm going to show you two ways to load the datasets in Mnova. One will be just by opening the folder containing the datasets. I hope that all of you will receive the zip file containing the datasets, so you will need to unzip it, and you will find some files inside. You will find a folder containing several datasets there, in that case, a few of them, but I will just click on the folder and drag into Mnova. So you select the folder and drag into Mnova. And after doing that, you will load in all the datasets included in that folder. So again, you go to the folder, you select the folder containing all the datasets, and you click and drag into Mnova. So all the datasets inside that folder will be loaded, and you will obtain an Mnova document with 9 pages. So you can easily change from one page to another, as in PowerPoint, just by clicking on any of the pages. As we are interested,
I guess it's worth mentioning. Maybe you're going to do it, but this would basically be HSQCs acquired for different concentrations of the ligand. Against the protein. You're probably going to show that with the tables, but so just that people have the context, I just thought I mentioned it now.
Yeah, there are as Santi said, those are HSQC. You can see here the concentration in the title, the different protein ligand concentration will be like a reference. So only protein is in this HSQC. Here we have a concentration of 0.25, 0.5, but we will use those values in the next step. So here we have 3 different concentrations of the protein and ligand. Once you have loaded all of your datasets, you will be interested in generate the stack plot or the superimpose plot. To do that, you will need to select all the pages in the page navigator. So you could just click on all the pages by holding down the Shift key, or just right-click on any of the pages of the page navigator and select all, or Control-A as a shortcut. With that, you will select all the pages in the page navigator. So the next step will be to go to the stack ribbon here. So once we have selected all the pages in the page navigator, you will need to go to the stack ribbon and select superimpose items. So again, you select all the pages in the page navigator by doing Control-A. You go to the ribbon, to the stack ribbon, and you select superimpose items. And with that, you will get this plot, which will be the dataset containing all the spectra in overlay mode. You could use the set key to expand the region of interest, and you can see all the spectra in overlay mode. That will be the first way to import your datasets. So basically, you click and drag the folder containing the datasets, you select all the pages in the page navigator, and then you select all the pages in the page navigator, and then you follow the menu stack, superimpose items, and you will get the superimpose spectrum. The next method, let's create a new document by following the menu File, New, or by using the shortcut Control-N, File, New, or Control-N to create a new document. And I'm going to show you a different way to import your datasets, which will be by using an script. To do that, just click on the Tools ribbon here, Tools, the Tools ribbon in your Mnova graphical user interface, and select the Import button. So you go to Tools, Import, and the first script on the scroll down menu will be the directory spectra stack. So basically you click on it, and it will display a dialog with several options. The first options will be the data folder. Here, if you will need to click on the three dots button to browse in your hard disk to find the folder containing your datasets. So you go to the Binding Workshop folder, you select the folder containing your datasets, you select that folder, and the path of your datasets will appear here. The next important step will be to make sure that you're using the correct file name mask. In that case, we are working with HSQC. They are Bruker datasets, so make sure that the ser mask is added there. If you don't have it, you can just manually type, or you could select the ser file from the scroll down menu. There is a button here which will be the preview files. If you click on it, it will display the list of all the datasets that will be opened with this script. So again, you go to Tools, Import, you select the folder containing the datasets, you make sure that you are adding the ser file in the file name masks, and then you will be interested in getting the spectra in superimpose mode. In the case that you prefer to get them in a stack, there is an option here, but in that case, we are going to use the superimpose mode. And in the palette, there are different options. I'm going to use the hue. So once you have selected the folder containing the datasets, the file name mask, and the superimpose mode, you will only need to click on the OK button. That will automatically go to the folder containing the datasets, import all the datasets, and create the superimpose plot just in one step. So the same workflow that we applied in the previous step, but just with a couple of clicks. If you remember, before we loaded the data sets and we created the superimposed plot. In that case, we used the script to create that plot. Okay, so once we have the spectrum in the superimposed mode, we could use the set key to apply the zoom in, or you could follow the menu View, Zoom in to expand the region of interest. So we could select that region, for example. And now let's play around with the binding tool. We go again to the Tools ribbon. If you remember, under the Tools ribbon was where we use it to import the data sets. But in that case, I'm going to click on the chemical shift perturbation button. This button here with the red brick. So you click on it, and it will display the chemical shift perturbation dialog. The next step will be just to apply the new analysis just by clicking on the blue plus button. So you go to Tools, Chemical Shift Perturbation. You click on the blue plus button. You could type a name if you are interested. For example, type a name for this analysis. Oops, let's this. And here in this panel, you will need to type the values belonging to the protein concentration. In that case, we're using micromolar, and the user should know the concentration value of the protein. In that case, is 500 micromolar. And then you will need to type or the ligand concentration or the ligand protein concentration values. In that case, for the first, is just 0. In the second, we have 0.25. For the third, 0.5. 1 for the fourth, 2, 3, 3, 5, 7, and 9. So we know those values because we acquired the data sets, and you know that the ligand protein concentration for the first is 0, 0.25 for the second, 0.5, 1, 2, 3, 5, 7, 9. Okay, so once we have filled
Pablo, sorry, I just jumped in for a second. You could also instead enter the concentration of the ligand in the middle column.
Yeah.
And that will calculate the
ligand protein. Yeah, it doesn't matter.
Whichever way.
So you could, exactly. Yeah, you could fill this column or this one.
And the other one will be calculated.
Yeah, exactly. Mm-hmm. Yeah. So the next step, once you have filled the information with the protein concentration and the ligand concentration or the ligand protein concentration, will be to select the peaks of interest. So the peaks that you want to analyze the chemical shift perturbation. So to do that, you select the peaks tab here in the chemical shift perturbation panel, and you click on this button to select peak. And then you go to your overlay spectrum and you click on the peak that you want to analyze. And that's it. Automatically will picking all the spectra in the overlay plot, and the chemical shift perturbation analysis will be calculated. So you will find here the values of that chemical shift perturbation, the experimental and the calculated, and you will get the plot of those values. You could rename, for example, that series. So you could say, okay, this is my, I don't know, my 11 NH proton or whatever. So it will be renamed. You will get the label, the peak label here, and you could continue adding more peaks. For example, this one, and the series will be added, or this one, or this one, or you could add as many series as you want, and you could check there the results, and the graphics. And if you go to the Peaks tab, you will get the table with all the results and with the average KD value. If for some reasons you are not interested in any of those calculations because you check that it's wrong or whatever, you could just uncheck the box and the average KD value will be automatically calculated, recalculated. If you want to check any of the series, you could just double click on it and the series will be expanded for your analysis, for your review. So you could go back, you could check the series or whatever. Once you have finished, you could just report the result just by selecting this option here, report, and the table will be added to your spectrum. You could click on the F key to display the full spectrum, and you will get the table on your dataset. So, summarizing, you will need to import your dataset just by clicking and dragging the datasets into Mnova, and then created the stack plot or the superimposed plot, or use the tools import directory spectra stack to import the datasets and create the superimposed dataset. Once you have the superimpose, you will need to go to Tools, Chemical Shift Perturbation, and fill the table with the information of your protein concentration, ligand concentration, or the ligand protein concentration. Once you have filled the table, basically you go to the Peaks tab, you click on the Select Peak, and you add the peak or the peaks that you want to analyze. And that's it. You click on you go again to the peaks table, and you could report the peaks table, the results of your KD analysis. That will be the manual way. We have also a feature to automatically do this job with a few clicks. In that case, to do that, you will need to have some text files, including the information of the protein ligand. So if you go to the folder containing the datasets, you will have a ligand text file. You can open it, and in this case, it will just contain the information about the ligands. If you open the peak list file, you will have the information about the peaks that you want to analyze and some assignment labels there. So in that case, for the assignment of the nitrogen 9, the peak will appear at these chemical shift values. And you will have also a titration file, which will contain the information about the ligand protein concentration. So those values that I manually type. In that case, you will provide those values in a text file, which should be in this format. So how we can work with that? Let's create a new document, File New, and you go to Tools, Chemical Shift Perturbation, and here you will see this button with this yellow folder, which is to create a titration document. You click on it, and it will display a dialog. The first field will be to select the folder containing your datasets. So you click on the 3 dots button, you browse in your hard disk, so you go to the folder containing your datasets, Binding Workshop, and you select the folder which contains the 9 HSQCs. You select that folder, and you do the same with the titrations file, which was here. The same with the ligands file, which is here, and the same for the peaks file, which contains the cross peaks that you want to analyze. You could create a report file, for example, like this, for the results. You could add a processing template if you are interested in it, but this is not mandatory. And you click on OK. Clicking on the OK button will automatically import all the HSQC that you have in that folder. Will create the superimpose spectrum, will do the peak picking, and will do the chemical shift perturbation analysis. So at the end, you will have your Mnova document with the peak picking, with information about those KD values, the average KD, and again, you could just select the peak to verify that all the analysis is correct, or that you don't have any peak behind or whatever. And again, if you are not happy with any of the calculations, you could just uncheck it, and the average KD will be updated. So summarizing, you will basically need to import the dataset, create the superimposed spectrum, follow the menu tools, chemical shift perturbation, select the peaks that you want to analyze, and just get the results and report them in your dataset. You could do it in that way, or you could use the script to select the folder containing the datasets and the text file containing the information about your titrations, your ligands, and your peaks. And that's it. Let me pass to Santi.